marker in. Let's go into the Singleton pattern here. This chapter is an anomaly. Every other chapter in this book shows you how to use a design pattern. This chapter shows you how not to use one. Despite noble intentions, the Singleton pattern described by the Gang of Four usually does more harm than good. They stress that the pattern should be used sparingly, but that message was often lost in translation to the game industry. Like any pattern, using Singleton where it doesn't belong is about as helpful as treating a bullet wound with a splint. Since it's so overused, most of this chapter will be about avoiding singletons. But first, let's go over the pattern itself. When much of the industry moved to object-oriented programming from C, one problem they ran into was, how do I get an instance? They had some method they wanted to call but didn't have an instance of the object that provides that method in hand. Singletons, in other words, making it global, were an easy way out. Monoids for the win, yes. The Singleton pattern. Design pattern summarizes singletons like this. Ensure a class has one instance and provide a global point of access to it. We'll split that at and consider each half separately. Restricting a class to one instance. There are times when a class cannot perform correctly if there's more than one instance of it. The common case is when a class interacts with an external system that maintains its own global state. Consider a class that wraps an underlying file system API. Because file operations can take a while to complete, our class performs operations asynchronously. This means multiple operations can be running concurrently, so they must be coordinated with each other. If we start one call to create a file and another one to delete that same file, our wrapper needs to be aware of both to make sure they don't interfere with each other. To do this, a call into our wrapper needs to have access to every previous operation. If users could freely create instances of our class, one instance would have no way of knowing about operations that other instances started. Enter the singleton. It provides a way for a class to ensure at compile time that there is only a single instance of the class. I think one of the things that I've noticed though is a lot of people use singletons where it's you can't use more than one instance of it, but they don't also have protections in to check that it's being called more than once. So that actually could be pretty bad. Providing a global point of access. Several different systems in the game will use our file system wrapper, logging, content loading, game state saving, etc. If those systems can't create their own instances of our file system wrapper, how do they get a hold of one? Singleton provides a solution to this too. In addition to creating the single instance, it also provides a globally available method to get it. This way, anyone anywhere can get their paws on our blessed instance. Altogether, the classic implementation looks like this. Okay, so we have a class file system, public, okay, so file system, okay, so they have an instance method that you call if okay, so if an internal instance is null. Implementation in Rust, lazy static. I didn't think about this pattern in Rust. I suppose so. I think it's very easy to do this one in Rust because there's no way to create just an object on its own, essentially. You have to create like a struct, which then could be a singleton, essentially. But something I'm noticing now is like singleton is not just a class that's called once. It's a class that's written in a very specific way to be called once. But what I've been doing is I've been basically taking these examples that are written in C++ and converting them over to JavaScript, just to sort of make it a little bit more understandable what's happening. So we have our class file system. We're not following the one true bracket pattern here. So we're just having an instance method. An instance method it's going to check to see if there is a this.instance. Let's go ahead and add a constructor in here. And that's going to say this.instance equals, we should probably do this dot like stored instance equals null. So then when we call the instance method, it's going to check, okay, so is this dot stored instance. So if this dot stored instance is equal to null, then return this dot stored instance equals a new file system. So sort of like self-referential a little bit. Oh no, we're going to store it. Okay, this is sort of equals this, and then return that, a reference to it, essentially. And there is no such thing as this entire private stuff. Everything's public in JavaScript, you know, for reasons. All right, so this is what that looks like in JavaScript. The static instance member holds an instance of the class, and the private constructor ensures that it is the only one. The public static instance method grants access to the instance from anywhere in a codebase. It is also responsible for instantiating the singleton instance lazily the first time someone asks for it. A modern take looks like this. Okay, so we have class file system. We have the instance method. Interesting. So we have instance equals new file system return instance. Return a reference to instance. Well, this definitely wouldn't work in Rust. That's going to be dead by the end of this. So they basically create a little spot of memory for the file system and then return a reference to that file system. C++11 mandates that the initializer for a local static variable is only run once, even in the presence of concurrency. So, assuming you've got a modern C++ compiler, this code is thread safe, where the first example is not. Of course, the thread safety of your singleton class itself is an entirely different question. This just ensures that the initialization is. Well, yeah, and so there's not really a good class for this in JavaScript. This one would be better for JavaScript. You basically cache the stored instance, and then you can use that over and over again. Why we use it? It seems we have a winner. Our file system wrapper is available wherever we need it, without the tedium of passing around everywhere. The class itself cleverly ensures we won't make a mess of things by instantiating a couple of instances. It's got some other nice features too. It doesn't create the instance if no one's using it. Saving memory and CPU cycles is always good. Since the singleton is initialized only when it's first accessed, it won't be instantiated at all if the game never asks for it. It's initialized at runtime. A common alternative to singleton is a class with static member variables. I like simple solutions, so I use static classes instead of singletons when possible. But there's one limitation static members have: automatic initialization. The compiler initializes static before main is called. This means they can't use information known only once the program is up and running, for example, configuration loaded from a file. It also means they can't reliably depend on each other. The compiler does not guarantee the order in which statics are initialized relative to each other. Lazy initialization solves both of those problems. Now, the singleton will be initialized as late as possible, so by that time any information it needs should be available. As long as they don't have circular dependencies, one singleton can even refer to another when initializing itself. So And this is something that like the game developers that at my company have been talking about, which is once you start using singletons, you just sort of feel that it's taking you down a path where you're now forced to use more and more and more singletons, which is harder and harder and harder to do, or at least to get out of. You can subclass the singleton. This is a powerful but often overlooked capability. Let's say we need our file system wrapper to be cross-platform. To make this work, we want it to be an abstract interface for a file system with subclasses that implement the interface for each platform. Here is the base class. Okay, so we have a file system that's really, just showing a constructor, read file, and write file. Okay, so this is basically going to be a wrapper around file system, I guess. So let's comment that out. Essentially, we're going to have a class file system, which is, I guess it'll have a constructor, but nothing's really going to happen in it here. I guess what's more important is that we're going to have this read file method that takes in a path and doesn't do anything with it. And we're going to have a write file that takes in a path and contents. And again, doesn't really do anything with it because this is essentially the interface for it. Dependency injection is a more easily testable pattern, but I always feel like hunting the origin of those dependencies is a nightmare. It can be. It can definitely be a nightmare if they're not like put in a. If people try to do something like, okay, we have a folder for all of the dependencies. We have a folder for all these things. We have a folder for all these things. It can be really tough with that. I don't know if dependency injection is gonna be covered in this book. And it's something I'm still trying to figure out properly in Rust because like the types that are coming in. I think generics might help with that, but I'm not completely sure. Or I have to do it like in a traditional OOP method where I wrap the dependency in a struct and then pass that struct in, an instance of that struct in, which would then essentially be like the singleton pattern. Okay, so then we define derived classes for a couple of platforms. So like the PS3 file system. So I guess if I use theirs, class PS3. Anybody writing JavaScript for the PS3, that would be the best. Yeah, totally. Should get on that. Okay, so we're gonna have, now we implement like read file and write file. So this is going to extend file system. And so then here we're gonna have our read file, which takes in a path and does the read file stuff. And the write file, which takes in the path and the contents and writes to a file. And then of course we could have more and more and more, but I think this is enough of an example for that. So this is using inheritance, but I don't necessarily think this is like the bad style of inheritance yet. But I think that's because I'm not really inheriting. I'm inheriting this mostly as a method of architecture to basically state this file system implements these, and that's it. Like nothing less. Maybe like, and potentially nothing more either. Yeah, it should be nothing more in that case too, because it's an interface. Next, we turn file system into a singleton. Okay, so file system, we have the entire file system thing, but now we're going to have this instance coming out of here. So instance and okay, so we have static instance. I don't see instance implemented yet. The clever part is how the instance is created. Okay, so file system instance. If platform is PlayStation 3, stack file system instance equals the OCOM world. I don't know. Is it OCOM, or was it something else? For some reason I thought it was something else that started with O. But I don't remember off the top of my head. I know that like Smalltalk and C++ were like the two competing OOP methodologies, and they were very, very, very different from each other. And then essentially Java just came in and ate Smalltalk's lunch. Oh, Camel. Okay, right, that's it. Oh, Camel. I've never used or actually seen any OCaml code. Yeah, it's crazy how many of these things were invented in like the 60s. And we make fun of like programming in these old languages from then, but like all of our paradigms are from them, and we just have new languages. Okay, so we have instance, if platform, interesting. So clearly up above here, we're going to have like a const platform equals okay, like whatever the current platform is. So this would make the most sense to do something like process.env platform, and then the other one would be like PlayStation 3. Well, okay, so const PlayStation 3 would probably be something like PS3 or whatever is going to come in to here. So we'll just say that this is the string PS3. Then and then we can have another one. So const actually PS3 or like we or PS2. Okay, so we'll do one more. Const call this we equals we. And so then here in instance, we're not taking anything in. It's just going to be aware of these constants that we have here for us. And we can just do these. This is the hashtags in front of them are weird because that makes it look like it's a comment. But I guess it's just this is how ifs are done in C++. Okay, so if our platform is exactly equal to PlayStation 3, then static file system instance. So this is also where we probably need, at least for the JavaScript side of things, we need to hold this dot instance equals null. So to begin with, if this dot instance exists, then we're going to return this dot instance, and that's it right there. Otherwise, we're going to set this dot instance inside of this if else like series of blocks. So if the platform is the PlayStation 3, then this dot instance is going to be equal to a new like PS 3 file system, like that. Else if platform is exactly equal to the Wii, then set instance to Wii file system. And then finally, at the very end, we're going to return this dot instance. So we'll do an early return if we already have it. So that'll be a little bit faster. Otherwise, we instantiate it the first time and then return it. So it feels to me like a bit of a caching pattern. With a simple compiler switch, we bind our file system wrapper to an appropriate concrete type. Our entire codebase can access the file system using file system instance without being coupled to any platform-specific code. That coupling is instead encapsulated within the implementation file for the file system class itself. This takes us about as far as most of us go when it comes to solving a problem like this. We've got a file system wrapper, it works reliably. It's available globally, so every place that needs it can get to it. It's time to check into code and celebrate with a tasty beverage. If is a preprocessor, stuffs for the compiler, so they calculate compile time, not runtime. Oh, thank you, Fulisak. I did not realize that. Okay, that's pretty cool. Does Rust have something like that? I know Rust is getting more and more compiler time, like evaluation stuff. I think like the const keyword will do compile time evaluation. And that's it. I bet that's exactly what it is. Forgetful. I bet that's exactly what it is. What do I hate about Rust? I don't know if I necessarily hate anything about Rust at this point in time. Rust is fairly like tells you exactly what to do, but I don't think I hate anything about it. So we have a normal if for runtime too. Okay, so that would be if without the hash mark in front of it. Ccoder gr. Yes, it's a preprocessor directive. If PlayStation is defined, only that line is compiled and the other code is stripped. Ooh, nice. So I guess that's a nice way to do work ahead of time to make runtime a little bit faster. Why we regret using it. In the short term, the Singleton pattern is relatively benign. Like many design choices, we pay the cost in the long term. Once we've cast a few unnecessary singletons into cold, hard code, here's the trouble we've brought ourselves, or we've bought ourselves. It's a global variable. When games were still written by a couple of guys in a garage, pushing the hardware was more important than ivory tower software engineering principles. Old school C and assembly coders used globals and statics without any trouble and shipped good games. As games got bigger and more complex, architecture and maintainability started to become the bottleneck. We struggled to ship games, not because of hardware limitations, but because of productivity limitations. So we moved to languages like C++ and started applying some of the hard-earned wisdom of our software engineer forebears. One lesson we learned is that global variables are bad for a variety of reasons. They make it harder to reason about code. Say we're tracking down a bug in a function someone else wrote. If that function doesn't touch any global state, we can wrap our heads around it just by understanding the body of the function and the arguments being passed to it. Computer scientists call functions that don't access or modify global state pure functions. Pure functions are easier to reason about, easier for the compiler to optimize, and let you do neat things like memoization, where you cache and reuse the results from previous calls to the function. While there are challenges to using purity exclusively, the benefits are enticing enough that computer scientists have created languages like Haskell that only allow pure functions. Now imagine right in the middle of that function is a call to some class global data. To figure out what's going on, you have to hunt through the entire code base to see what touches that global data. You don't really hate global state until you've had to grep a million lines of code at 3 in the morning trying to find the one errant call that's setting a static variable to the wrong value. I think also something that's interesting is new tooling is available that makes it easier to find files in a code base, which is going to make the pain of this less, which in a way actually makes it easier to continue down the path of bad architecture longer and not really feeling a pain. Because if I want to find, one of those files, we're like, well, what was that? Let me do Control P, and then I can type. I'm actually looking only through like this file. So like, okay, Singleton Pattern, but I can find all these other ones here, and then we're good. So grep is free now, at least until you have like way more code or a lot of files that are named exactly the same because somebody hates you. That would usually be our previous selves. They encourage coupling. The new coder on your team isn't familiar with your game's beautifully maintained, loosely coupled architecture, but he's just been given his first task. Make boulders play sounds when they crash onto the ground. You and I know we don't want the physics code to be coupled to audio of all things, but he's just trying to get his task done. Unfortunately for us, the instance of our audio player is globally visible, so one little include later and our new guy has compromised a carefully constructed architecture. Without a global instance of the audio player, even if he did include the header, he still wouldn't be able to do anything with it. That difficulty sends a clear message to him that those two modules should not know about each other, and that he needs to find another way to solve his problem. By controlling access to instances, you control coupling. This is actually one of the problems, good things, bad things, sort of murky areas of JavaScript, because there is no such thing as privacy yet. So therefore, it's very easy to rot the code by adding in like everything and just like, well, hey, I can see it, so therefore I can use it. It's like, well, we want to really be stringent about our use of like where things are and how we use them. Which is, I think, one of the reasons why, React and Angular and Vue are so popular right now is because they kind of enforce that just a little bit. They aren't concurrency friendly. The days of games running on a simple single-core CPU are pretty much over. Code today must at the very least work in a multi-threaded way, even if it doesn't take full advantage of concurrency. When we make something global, we've created a chunk of memory that every thread can see and poke at, whether or not they know what other threads are doing to it. That path leads to deadlocks, race conditions, and other hell-to-fix thread synchronization bugs. Unless we use Rust, which won't let us write in the bad way. Issues like these are enough to scare us away from declaring a global variable, and thus the singleton pattern too. But that still doesn't tell us how we should design the game. How do you architect a game without global state? There are some extensive answers to that question. Most of this book, in many ways, is an answer to just that. But they aren't apparent or easy to come by. In the meantime, we have to get games out the door. The singleton pattern looks like a panacea. It's in a book on object-oriented design patterns, so it must be architecturally sound, right? And it lets us design software the way we have been doing it for years. Unfortunately, it's more placebo than cure. If you scan the list of problems that globals cause, you'll notice that the singleton pattern doesn't solve any of them. That's because a singleton is a global state. It's just encapsulated in a class. It solves two problems even when you just have one. The word "and" in Gang of Four's description of singleton is a bit strange. Is this pattern a solution to one problem or two? What if we have only one of those? Ensuring a single instance is useful, but who says we want to let everyone poke at it? Likewise, global access is convenient, but that's true even for a class that allows multiple instances. The latter of those two problems, convenient access, is almost always why we turn to the Singleton pattern. Consider a logging class. Most modules in the game can benefit from being able to log diagnostic information. However, passing the instance of our log class to every single function clutters the method signature and distracts from the intent of the code. The obvious fix is to make our log class a singleton. Every function can then go straight to the class itself to get an instance. But when we do that, we inadvertently acquire a strange little restriction. All of a sudden, we can no longer create more than one logger. At first, this isn't a problem. We're writing only a single log file, so we only need one instance anyway. Then, deep in the development cycle, we run into trouble. Everyone on the team has been using the logger for their own diagnostics, and the log file has become a massive dumping ground. Programmers have to wade through pages of text just to find the one entry they care about. We'd like to fix this by partitioning the logging into multiple files. To do this, we'll have separate loggers for different game domains: online, UI, audio, gameplay, but we can't. Not only does our log class no longer allow us to create multiple instances, that design limitation is entrenched in every single call site that uses it. Log, instance, write, some event, right. Yeah, so we're calling this instance like a static instance directly on log because it's a singleton. And I wonder, like, before I go on, I wonder if a good solution to this is an event system where we just say, hey, here's an event and I would like it to be logged. And then the logger can catch like, ooh, somebody wants to log this. And then I'll just go ahead and log it. That still might be end up singleton, but it only gets run one area. I don't know. It'll be interesting to sort of see what the solution is. In order to make our log class support multiple instantiation, like it originally did, we'll have to fix both the class itself and every line of code that mentions it. Our convenient access isn't so convenient anymore. It could be even worse than this. Imagine your log class is in a library being shared across several games. Now, to change the design, you'll have to coordinate the change across several groups of people, most of whom have neither the time nor the motivation to fix it. Lazy initialization takes control away from you. In the desktop PC world of virtual memory and soft performance requirements, lazy initialization is a smart trick. Games are a different animal. Initializing a system can take time, allocating memory, loading resources, etc. If initializing the audio system takes a few hundred milliseconds, we need to control when that's going to happen. If we let it lazy initialize itself the first time a sound plays, that could be in the middle of an action-packed part of the game, causing visibly dropped frames and stuttering gameplay. Likewise, games generally need to closely control how memory is laid out in the heap to avoid fragmentation. If our audio system allocates a chunk of heap when it initializes, we want to know when the initialization is going to happen, so we can control where in the heap that memory will leave. See Object Pool for a detailed explanation of memory fragmentation. Because of these two problems, most games I've seen don't rely on lazy initialization. Instead, they implement the Singleton pattern like this. Okay, so we have the class file system, we have the static method instance that returns this.instance, and that's, I guess there's probably more to it than just that. Oh, so they can have like maybe they can have some other time that they call file system to set the instance. That solves the lazy initialization problem, but at the expense of discarding several singleton features that do make it better than a raw global variable. With a static instance, we can no longer use polymorphism, and the class must be constructible at static initialization time. Nor can we free the memory that the instance is using when not needed. Instead of creating a singleton, what we really have here is a simple static class. That isn't necessarily a bad thing, but if a static class is all you need, why not get rid of the instance method entirely and use static functions instead? Calling foo bar is simpler than foo instance.bar, and also makes it clear that you really are dealing with static memory. The usual argument for choosing singletons over static classes is that if you decide to change the static class into a non-static one later, you'll need to fix every call site. In theory, you don't have to do that with singletons because you could be passing the instance around and calling it like a normal instance method. In practice, I've never seen it work that way. Everyone just does foo instance bar in one line. If we changed foo to not be a singleton, we'd still have to touch every call site. Given that, I'd rather have a simpler class and a simpler syntax to call into it. So basically, it sounds like singleton pattern done in the proper way isn't terrible. But because so many programmers don't follow that pattern, and we know that new developers coming into the team won't follow that pattern, therefore we shouldn't hope, hey, everyone do the right thing. We know you're going to do the right thing. If we look at like why Rust is getting more popular, it's because we can't trust ourselves to do the right thing because we know what it is, but we have the power not to do that because we'll always do the bad thing, or we'll often do the bad thing, which, I mean, that's where all these problems come from. What we can do instead. If I've accomplished my goal so far, you'll think twice before you pull singleton out of your toolbox the next time you have a problem. But you still have a problem that needs solving. What tool should you pull out? Depending on what you're trying to do, I have a few options for you to consider. But first, see if you need the class at all. Many of the singleton classes I see in games are managers, those nebulous classes that exist just to babysit other objects. I've seen code bases where it seems like every class has a manager. Monster manager, particle manager, sound manager, manager. Sometimes, for variety, they'll throw a system or engine in there, but it's still the same idea. Well, caretaker, I've actually done the engine one myself in a long time ago. While caretaker classes are sometimes useful, often they just reflect unfamiliarity with OOP. Consider these two contrived classes. So we have a class bullet. So get x, get y, set x, set y are the two public methods that are just going to get and set. Private for that. And then we have the bullet manager. So the bullet manager, we're going to have a create. Okay, so the bullet isn't even going to create itself. These are just fully public. So bullet manager, we're going to create. So here's where we can create the new bullet. It also does the initial setting and returns the instance of the new bullet. Is on screen. So this is where all the logic. So I've not been doing this pattern with the infinite runners because I've just been putting the logic inside of them. Hey, player, are you off the screen? Object, are you running into the player? Object, are you off the screen? Object, time to reset yourself. All of those just went into, for example, what here would be the bullet class. Maybe this example is a bit dumb, but I've seen plenty of code that reveals a design just like this after you scrape away the crusty details. If you look at this code, it's natural to think that bullet manager should be a singleton. After all, anything that has a bullet will need the manager too. And how many instances of bullet manager do you need? The answer here is 0, actually. Here's how we solve the singleton problem for our manager class. So I'm going to implement this one, and then we'll refactor it as part of this code here. So we have our class bullet, which is going to have a constructor, and we're going to do this.x, this.y. So it's all it has is its location. We're going to have a get x, which is going to return this.x. We're going to have a get y, which is going to return this.y. We're we're going to have a set x, which is going to have an x. And we're going to set this dot x equals x. Set y takes in a y. This dot y equals y. And then we're going to have our bullet manager. So class bullet manager. And so probably have a constructor. Let's see. So in bullet manager, we have a create method. So let's add that in here. So we have a create bullet, which is going to take an x and a y for where to create the bullet. And we're going to create the new bullet. So const bullet equals new bullet, like that. And then we're going to say, okay, bullet dot set x, pass it x, bullet dot set y, pass it y, return the bullet. And then we're going to have our is on screen that returns a boolean. So is on screen. We're going to take in a bullet. And then we're going to do this entire fun thing where it's like, hey, are you on the screen? So basically, calculate if bullet is on screen, return boolean. And then we have this void, so like the actual move command. So it's updating the like the velocity of it. So instead of like holding a velocity, apparently we're just making it fly left or right straight. So we're gonna have move, takes in a bullet, and we're gonna say bullet dot set x, need a bullet dot get x plus 5, whatever. So I move 5 pixels to the right. Perfect pattern. What could possibly be wrong with this? Let's see. Okay, so here's how we solve the Singleton pattern for this class. We have class bullet, public. So this is the constructor. So yes, this is the before we refactor away from Singleton, after refactoring. So now we're going to have just our bullet. I don't think we're going to need a manager for this. And we're going to say, okay, well, in our constructor, we're going to have an x and a y. And this way we say, well, okay, our this dot x equals x, this dot y equals y. We have our bool is on screen. Okay, so we have is on screen. It doesn't even take an x and y. We just go ahead and say return true, false if on screen or not. And then we have move, which then this here is this dot x plus equals to 5. And then in this case, we don't need any of these setters and getters anymore. Just nice small class. There we go. No manager, no problem. Poorly designed singletons are often helpers that add functionality to another class. If you can, just move all that behavior into the class, it helps. After all, OOP is about letting objects take care of themselves. Outside of managers, though, there are other problems where we'd reach to Singleton for a solution. For each of those problems, there are some alternative solutions to consider. to limit a class to a single instance. This is one half of what the Singleton pattern gives you. As in our file system example, it can be critical to ensure that there's only a single instance of a class. However, that doesn't necessarily mean we also want to provide public global access to that instance. We may want to restrict access to certain areas of the code, or even make it private to a single class. In those cases, providing a public global point of access weakens the architecture. For example, we may be wrapping our file system wrapper inside another layer of abstraction. We want a way to ensure single instantiation without providing global access. There are a couple ways to accomplish this. Here's one. Okay, so we have our file system class, our constructor, assert that it's not instantiated so far. File system instantiated equals false. Private static, okay, instantiated, and then we're gonna set. This is outside of the class. That's where the class ends. So we set a static method off of here to false. I don't know if we can do this in JavaScript. I don't know if it would remember. I've actually never tried anything like this before. But okay, we're gonna set it to be false. So it's not instantiated. Also public and private. How can I set this to be false if it's private? Interesting, okay. This class allows anyone to construct it, but it will assert and fail if you try to construct more than one instance. As long as the right code creates the instance first, then we've ensured no other code can either get at the instance or create their own. The class ensures the single instantiation requirements it cares about, but it doesn't dictate how the class should be used. Yeah, I don't know how I could do this in Rust or JavaScript properly without using a global. An assertion function is a way of embedding a contract into your code, where when assert is called, it evaluates the expression passed to it. If it evaluates to true, then it does nothing and lets the game continue. If it evaluates to false, it immediately halts the game at that point. In a debug build, it will usually bring up the debugger, or at least print out the file and line number where the assertion failed. An assert means I assert that this should always be true. If it's not, that's a bug and I want to stop now so you can fix it. This lets you define contracts between regions of code. If a function asserts that one of its arguments is not null, that says the contract between me and a caller is that I will not be passed null. Assertions help us track down bugs as soon as the game does something unexpected, not later when that error finally manifests as something visibly wrong to the user. They are fences in your codebase, corralling bugs that can't escape from the code that created them. The downside with this implementation is that the check to prevent multiple instantiation is only done at runtime. The Singleton pattern, in contrast, guarantees a single instance at compile time by the very nature of the class's structure. To provide convenient access to an instance. Convenient access is the main reason we reach for singletons. They make it easy to get our hands on an object we need to use in a lot of different places. That ease comes at a cost, though. It becomes equally easy to get our hands on the object in places where we don't want it being used. The general rule is we want variables to be as narrowly scoped as possible while still getting the job done. The smaller the scope an object has, the fewer places we need to keep in our head while we're working on it with it. Before we take the shotgun approach of a singleton object with a global scope, let's consider other ways our codebase can get access to an object. Pass it in. The simplest solution, and often the best, is simply to pass the object you need as an argument to the functions that need it. It's worth considering before we discard it as too cumbersome. Some use the term dependency injection to refer to this. Instead of code reaching out and finding its dependencies by calling into something global, The dependencies are pushed into the code that needs it through parameters. Others reserve dependency injection for more complex ways of providing dependencies to code. Consider a function for rendering objects. In order to render, it needs access to an object that represents the graphics device and maintains the render state. It's very common to simply pass that in to all of the rendering functions, usually as a parameter named something like context. On the other hand, some objects don't belong in the signature of a method. For example, a function that handles AI may need to also write to a log file, but logging isn't its core concern. It would be strange to see logs show up in its argument list. So for cases like that, we'll want to consider other options. Terms for things like logging that appear scattered throughout a codebase is cross-cutting concern. Handling cross-cutting concerns gracefully is a continuing architectural challenge, especially in statically typed languages. Aspect-oriented programming was designed to address these concerns. Aspect-oriented programming takes us to a Wikipedia article. Programming paradigm that aims to increase modularity by allowing the separation of cross-cutting concerns. It does so by adding additional behavior to existing code without modifying the code itself. Instead, separately specifying which code is modified via a point cut. Okay, this might be interesting to look at. I guess more for the Rust side than for the JavaScript side. Get it from the base class. Many game architectures have shallow but wide inheritance hierarchies, often only one level deep. For example, you may have a base game object class with derived classes for each enemy or object in the game. With architectures like this, a large portion of the game code will live in these leaf-derived classes. This means that all of the classes already have access to the same thing, their game object-based class. We can use that to our advantage. Okay, so we have class game object, protected, log, get log. Okay, so we're gonna get the log from this. Private, we just have our static log. And then we have another enemy, which extends from game object that has do something. It gets the log. Where does it get log from? Like, it just calls get log, but it's not like embedded inside of it. I guess somebody else creates it and then it's just globally available now. This ensures nothing outside of game object has access to its log object, but every derived entity does using getLog. This pattern of letting derived objects implement themselves in terms of protected methods provided to them is covered in the subclass sandbox chapter. This raises the question, how does game object get the log instance? A simple solution is to have the base class simply create and own a static instance. If you don't want the base class to take such an active role, you can provide an initialization function to pass it in, or use the service locator pattern to find it. Pollux, you feel like moving away from React and starting to use you. You don't know why you feel this way? Well, maybe because it's like all Rust stuff, and you want to use Rust. As an alternative, you'd be more curious in Elm. So I've heard Elm, and I know some people that use it, but I haven't checked it out myself. I also haven't really spent any serious time looking at you either. And also chuck everything to do with JavaScript and move to a full stack Rust. That's getting more and more doable these days. As long as all the browsers keep on moving forward and implementing WebAssembly, I mean, it's looking like we can do that soon. Maybe not completely yet, but at least you can get rid of a lot of the JavaScript. Get it from something already global. The goal of removing all global state is admirable, but rarely practical. Most code bases will still have a couple of globally available objects, such as a single game or world object representing the entire game state. We can reduce the number of global classes by piggybacking on existing ones like that. Instead of making singletons out of log, file system, and audio player, do this. Okay, so we have a class game. We have an instance that returns the instance, so it's the standard singleton pattern here. But then game itself has get_log, get_file_system, get_audio_player inside of it. So essentially, game is now a, what's the name of the pattern? It's a facade for everything else. So it doesn't actually implement them, but it stores them and provides access to them. This is sort of like a, I guess this is sort of like the manager pattern, but we just have like one manager for the entire game as opposed to individual components within the game. Pollux, you remember making your decision to become a full stack JavaScript dev 5 years ago. Seems like it's time to shift. Too much saturation. I don't know fully about, like, I guess it depends upon what level you are. If you're like a senior JavaScript developer, there's still plenty of room for that in the industry. And I think that just comes from like, there's so much crap out there dev-wise that we need so many more senior devs to like write good architecture for front-end development. And then how many people are really truly hiring for like web developers to not be JavaScript? I think it might take a little while before startups and bigger businesses start doing that. Like at a point where then we can get jobs for it. That being said, I still believe that learning Rust is like good future proofing, and that's why I'm getting myself leveling up in Rust too. With this, only game is globally available. Functions can get to other subsystems through it. Purists will claim this violates the law of Demeter. I claim that it's still better than a giant pile of singletons. If later the architecture is changed to support multiple game instances, perhaps for streaming or testing purposes, log, file system, and audio player are all unaffected. They won't even know the difference. The downside with this, of course, is that more code ends up coupled to game itself. If a class just needs to play sound, our example still requires it to know about the world in order to get the audio player. We solved this with a hybrid solution. Code that already knows about game can simply access audio player directly from it. For code that doesn't, we provide access to audio player using one of the other options described here. Get it from a service locator. So far, we're assuming the global class is some regular concrete class like game. Another option is to define a class whose sole reason for being is to give global access to objects. This common pattern is called a service locator and gets its own chapter. Okay, so we're going to go through that at a later time. What's left for Singleton? The question remains, where should we use the real Singleton pattern? Honestly, I've never used the full Gang of 4 implementation in a game. To ensure single instantiation, I usually simply use a static class. If that doesn't work, I'll use a static flag to check at runtime that only one instance of the class is constructed. There are a couple of other chapters in this book that can also help there. The subclass sandbox pattern gives instances of a class access to some shared state without making it globally available. The service locator pattern does make an object globally available, but it gives you more flexibility with how that object is configured. And that is the end of the Singleton chapter. I don't think I'm going to spend the next couple days implementing singletons into the code because it sounds like we would just want to rip them out for other patterns in the future. It sounds more of this is an argument for, hey, keep on reading. There are patterns that we're going to go over that allow you not to do the singleton pattern. So that's where we're going to go. We do, like, I have a couple minutes. Does anybody have any questions about like this, Rust, JavaScript, singleton pattern, any of the other patterns, random programming stuff? I'll be happy to give my thoughts on it. In the meantime, the next pattern is going to be the state pattern. And then at that point, we'll be getting into the the actual game development patterns created by, I guess not created by Robert Nystrom, but like discovered by the author throughout the game code bases that he's worked with in the past and organized here. What's my current pet peeve about programming now? I think my current pet peeve is the continued argument that management is bad, that sales is bad, that if only like our customers weren't here and asking for all these changes, then our code base would be like pure and awesome and everything would be great. I think that what that ends up being is that it caused this schism between the IT department and pretty much every other department around. And I think that really we want to go the opposite direction, tightly integrate engineering with all of the other departments, especially sales and marketing. And then by doing that, we won't run into those same problems. Like, oh, hey, marketing promised that we're going to have this feature out by like, 1 month from now, and it's going to take 8 months to develop. We want to like tightly integrate our departments with theirs so that we can have a seat at that table instead of like, isolating us further and further away and then eventually quitting whenever we're like, well, they kind of screwed us over because we don't ever talk to them. So there's that. That's my pet peeve. It's actually not really about programming. It's about culture in most companies, as it were. Ironically, I also think that that's one of the reasons why a lot of startups do so well at the very beginning. When you have like the CEO, you have like a CTO who's doing like the tech stuff, who's like building the app. Yeah, it's like 2 or 3 people at most. They're like so tightly integrating together that they're not running into those problems. The CEO's like who's doing marketing also knows exactly what's happening all the time with the code. The person doing the code knows exactly what's happening all the time with like the marketing efforts. And then you break things apart and you go, we need to go more enterprisey as like we grow to like 30 plus people. And suddenly now there's these firewalls between the groups and bad things start happening. Mainly people stop talking to each other. We have meetings that don't like the wrong types of meetings at the wrong times. All right, well, let me open up to, what do I call this? Get Kraken. I'm gonna open up Get Kraken and I'm gonna throw this code up onto GitHub. Let's take game design patterns. Here, this is learning Singleton, or where not to use Singleton. Save you, push you up. Let's go take a look. Oh, yeah, okay. I haven't logged in to GitHub on here. Okay, so it's builds, learning game design patterns. So here is the location where the code is because the bot is down due to DigitalOcean being down. I'll have to take a look at that later. But there's a link to the code. I just pushed up those 2 sort of like examples in the playgrounds file. As I said before, I don't think I'm going to implement those into the GGEZ or P5 Infinite Runner. I'll probably just move on to the next pattern, which is state, which sounds a little bit more interesting. So that will probably be tomorrow's plan. In the meantime, let's take a look at who is available. Go to twitch.tv. And am I not logged in? Oh, I'm logged in as the wrong user on this one. My Brooke Zerker bot. So not that one. Let's go in as this other browser. Twitch.tv. CJ is live.
Can't anymore? Is that what you mean? We're gonna put that in the parking lot. We'll come back to it. Full snack development.
Yeah, CJ is doing chill codes. Let's raid CJ. So
you kind of put.
Gonna mute that. Where's the raid button? Raid CJ. We'll start that raid. Everyone, I'm gonna switch over to my ending screen. Everyone, thank you so much for stopping by and watching. It's been great going through all these different patterns, learning and then implementing them into the code. I feel like my skill is improving, and I hope that if you're following along, you're also feeling that your skills are improving as well. I am doing these streams every single weekday morning at around 7 a.m. Mountain Time to around 8:15 or so in the morning before I have to go off and go to work. If you want to get notified, follow me here on Twitch, follow me on Twitter. I've got links down below in the description. And let's all be awesome to CJ, say hi to him, and have a great rest of our day, and I will see you tomorrow. And with that, I am hitting the raid. Bye!
People that have those questions, but it's potentially overwhelming to say, hey, I'm going to try to